This is question number 9 on June 2011 Unit 1 foundation paper. We've got somebody dropping different balls from the same height onto a wood floor. He measures the height of their bounce, and it says here to the nearest 0.2 meters. So we're going to do things if we can to the nearest 0.2s. And he has a frequency polygon here. So first of all, let's try and work out what on earth this means. Here, a bounce of 0.4 meters happened with 2 balls. Up here, we're level with 3. So 3 balls bounced to a height of 0.6. Now what it would be useful to do is put this from a graph into a table. So we're interested in the bounce and the frequency, which means how many times it happened. So there's a bounce of 0.4 2 times, a bounce of 0.6 3 times, a bounce of 0.8 9 times, a bounce of 1.0 4 times, a bounce of 1.2 3 times, and a bounce of 1.4 1 time. Now this should look like what you're familiar with, the frequency table. And to find the mean, you times these together. So that's the next thing we have to do. We have to times together 0.4 times by 2, that's 0.8. 0.6 times by 3, 1.8. 0.8 times by, no, it wasn't actually 9 there, I misread that one, that was 7. Okay, so I change that to 7. 0.8 times by 7, 5.6. 1.0 times by 4, 4.0. 1.2 times by 3, 3.6. 1.4 times by 1, 1.4. So I've times those together. What you then have to do is you add up those numbers. If you add those numbers up, and you can do that on a calculator, if you add those up, you get 17.2. And when you've done that adding up, you always have to divide by how many times it happened. And how many is what frequency means. So you need to add these numbers up here. And if you add these frequency numbers up, 2 and 3 make 5, add 7, it's 12, 16, 19, 20. That's the sum we have to do to get the mean. So again, you can use a calculator. And if we do 17.2 divided by 20, we get 0.86. So 0.86 meters was the mean height of the ball. So that is part A completed. Part B is a different sort of question altogether. It says Amir wants to test the hypothesis. So he's got a question, something he thinks is true. He thinks balls bounce higher on concrete than they do on wood. We've got to use the data handling cycle to write a plan for him to test this out. The data handling cycle is this. Data handling cycle. You specify the problem. Well, we've got the problem. The problem is to decide whether or not balls bounce higher on concrete than they do on wood. Then we have to collect the data. We have to process and represent the data. That may mean working out averages, drawing diagrams. And then we have to interpret the results. So this bit is already done for us. There are 3 things to do. Collect the data, process the data, and interpret the data. And those 3 things are what's needed here. And this is a 3-mark question. So the first thing we need to do is we need to collect the data. So the data we need to collect will be the measuring the bounces. So we need to write this down. We need to measure the bounces, how high they are, for wood and for concrete. So the first thing we're doing is collecting our data. The second thing it said in the data handling cycle was processing and representing the data. So processing means sort of working something out. So for example, if we work out the mean, the average, if I work out the mean height And I would need to do this for wood and for concrete. That's my processing bit. And then finally, my interpreting bit, what I have to do then is compare the means, compare the averages, and then whichever one had the higher average, I could then conclude that the higher average told me which one bounced the highest, and then I could compare my results with a statement up here, and I would know whether or not it was true or not. But 3 marks, 1 for saying about collecting data, 1 for saying about working something out from the data, and 1 for comparing them and interpreting your results and coming to an answer at the end.